Every one of these 130 questions in this problem set I'm going to share trips up high flyers that score over a 700 on SAT math. Not because they're not good at the math, but because these types of questions will punish you if you go on autopilot. I'm going to show you the first 10 today and the exact move that cracks each one. Stick around for number 10. It's the one you will not be able to do without knowing the formula. And spoiler alert, it is not on the reference sheet. If you're chasing a top SAT math score, this video is your hardest gym rep series. I've linked the document in the description below so you can work alongside me on all of these questions. And if you really like episode 1, comment below and let me know that you want to see more episodes. Otherwise, I might just stop doing them if no one likes them. All right, let's get into it. All right, guys, let's get into question number 1. X plus 13 is a factor of the quadratic function y equals f of x, and x equals c is a positive 0 of the function. If the minimum of the function is 51 over 8 comma k, what is the value of c? Okay, I'm going to break this down based on what I know about the SAT and what I need to extract. This is important information because it tells me there's a solution at negative 13. And then this basically is the axis of symmetry. And then they want to know what the other solution is, and it's going to be positive. So essentially, if we have a quadratic, and here's the x-axis, it crosses at negative 13. Our axis of symmetry is at 51/8, and then we want to know this point over here. All we need to use is the midpoint formula since the axis of symmetry is the midpoint. So I'll set it up as 51 over 8. That's the midpoint. It's going to equal negative 13 plus c. And that's divided by 2 because we want to know 51/8 is halfway between them, right? So now it's just simple solving. Let me get the denominators to be the same. I'll multiply that by 4 over 4. Okay, now the denominators are the same. I can get rid of them. And then what I'm going to do is divide by 4 on both sides. So I basically have 51 over 4 equals negative 13 plus c. I'm going to add 13 to both sides. Now 13 over 4 is going to be 52/4, right? So I really want to add 52/4 to 51/4. So I have 103/4. That equals c. All right, let's move on to the next one. So watch out for axis of symmetry. If they give you the x coordinate of the vertex, by the way, minimum is a keyword that means vertex. If you see maximum, also means vertex. So if you have the solutions or one of the solutions in the vertex, you're probably dealing with the axis of symmetry. All right, guys, if you haven't subscribed to this channel yet, I don't know what you're waiting for. I come out with free content every single week to help you master the SAT. So make sure you hit that button below and do yourself a favor today. All right, number 2, we have for two acute angles, angles A and B, cosine of A equals sine of B. Okay, when I see this on the SAT, I know they're testing me on the complementary angles rule, which basically states that angle A plus angle B will equal 90 degrees if the cosine of one of them equals the sine of the other one. So they said A is 9x plus 12. They said B is 51 plus 5x. I'm going to add those together and set it equal to 90 and solve for x. So I end up with 14x equals 14x plus 63 equals 90. Take 63 away. 14x equals 27. Divided by 14. So x is 27/14. Don't get sketched out if you get weird fractions. I can still fit it as an answer. I've got 5 spaces. 27/14. Often on the digital SAT, they're not going to be nice round numbers because they know you have access to the Desmos calculator. So sometimes the answers are going to be like weird decimals or fractions. Just roll with it. All right, number 3, we have a pottery studio charges each member $150 for the first month and $95 for each additional month. Which of the following functions correctly represents the total revenue, R of M, in dollars for M months and A members where M and A are positive integers? Okay, here's the thing. We have $150 for the first month, plus 95 for each additional month. So I need to multiply that by the total number of months, M, minus 1. Why am I taking 1 away? Because the first month was already counted for in the 150. So we don't want to recount that again. It's a different charge. That's month 1. And then 95 is the rest of the months. That's why we do it times M minus 1. Okay, if 150 was the first 2 months, then we would put M minus 2 in the parentheses and so on. Now, here's the thing that makes this one super sneaky tricky. This is just for one person. The person pays 150 for the first month and 95 for each additional month. They said they want to know how much it's going to be for A members. So if there's more than one member total, we have to multiply this whole thing by A, because that's just one person times all the people that there are. So essentially, I'm going to just simplify now. I have 150 plus 95M minus 95. I just distributed, right? And then I have 150 minus 95 is 55 plus 95M. Now I can distribute the A. That's how I end up with 95MA plus 55A. Your answer is going to be C. Now, here's one thing I want you guys to keep in mind with these hard Module 2 questions. Once you're getting in Module 2 and you're getting into the weeds of it, like halfway point towards the end, if a question like this shows up, expect the answer to have at least one number in it that's unexpected. 55 is nowhere to be found in the problem. So at first glance, you're thinking, how do we get 55A? That doesn't make any sense. But trust the process and work it out, because you're going to get a random number as part of the answer. You don't want to pick the other answers like B or D, because those have both numbers that are directly in the problem and something is going to be surprising. All right, guys, if you're finding this video helpful so far, show me some love, hit the like button below. It'll help other people find this video. All right, let's look at number 4. We have a quadratic and then we have a line. It says in the given systems of equations, K is a constant. The graphs of the equations in the given system intersect at exactly one point, x comma y, in the xy plane. What could be the value of x? Okay, here's the thing. If there's just one constant in the problem, that's great news. What I'll do is I'm going to use Desmos, and I'll have a slider for k, and then I can basically manipulate it to get what I want. They said they intersect at exactly one point. So I'm going to move k around until I make sure that those graphs only intersect one time. So let's go to Desmos and see how this works. Okay, guys, as you can see, I have both graphs up. And now I'm going to move k around, but let me get right in there so I can see when they intersect. So if I start moving k, what will happen is it's going to intersect at one point right on the side, and expect k to be an integer. So let me go to 8. And then you can see, oh, boom, it intersects right there at -2, -58. And that's the only place that it hits. So they wanted to know, what is the value of x? Well, x is -2. All right, guys, let's talk about number 5. So we have, for the given function f of x, which of the following gives the equation for the function f of x plus 18, given that the point -3, 0 lies on the graph of f of x minus 18. Okay, we're going to start with this information. And again, since we only have one constant, this is great for Desmos because we just have one slider. That's manageable. What I'm going to do in Desmos is I'm going to type this in, because we now want it to be f of x minus 18. This was f of x. We have to add a minus 18 onto the end of it. And then I'm also going to type into Desmos the point -3, 0, and I'm going to move the slider D around until it intersects that point. That's how I know what the value of D is. So let's do that right now. All right. So as you can see, we have our line and we have our point. Let me move D till it intersects that. Okay, it looks like D is 3. Awesome. So now we know D is 3. And they want to know what is the equation for f of x plus 18. Well, I have -5x plus 3 plus 18. So it's going to be negative 5x plus 21. Answer is D. All right, we're going to go to the next one, but I just want to say this next one breaks people. And we have this exact question in our SAT math workbook, which we're giving away for free if you subscribe to our email list. So I will link up here to our website. Go grab a copy of that math workbook so you can work on other problems just like this one. All right, let's take a look at number 6. The positive number x is 480% of the number y, and x is 70% of the number z. If z is 8% of y, which of the following is the closest to the value of a? Okay, solving these by hand takes longer and can be more confusing. So when you see these percentage problems that relate different variables to each other, you can actually use a list in Desmos. So what I'm going to do basically is show you guys, they said x is this, then they said x is this, and then they said z is this. So when I enter it into Desmos, I'm going to do x, z, tilde, 480% of y, 70% of z, and then a% of y. Now, I'll show you this. You're going to get an error message because x's and y's don't work in Desmos. Spoiler alert, but I just want you to see what happens so that you're aware. Okay. So when I hit this error message, it says x may not be used as a regression parameter. It's going to tell you the same thing for y as well. So what you'll want to do is change the x's to a different value and the y's to different values. So like we'll convert the x's to a's and we'll convert the y's to c's. Okay, just to keep track. All right, now you'll see the beauty of Desmos is it does all the work for you. The question said, what is the closest value of a? It spit it out beautifully for us. It's 685. So we're going to go ahead and pick D. All right, let's look at number 7. We have the exponential function given above passes through points c, 12 and 2c, 222. What is a possible value of b? Now with this, I can run a regression because I have the equation and I have 2 points. I have point 1 and point 2. Now the thing is they made these ambiguous, but they relate to each other. The x coordinate in the first point will then double for the second point. So I could try 2, 12 and 4, 222. I could try 4, 12 and 8, 222, etc. What's interesting is you'll notice it doesn't change the answer. So you can pick any value for C that you want and then just double it for the second point and you'll be able to get your value of B. Let me show you how that works. So first thing I'm going to do when I run a regression is I'm going to type table and I'm going to go ahead and throw in the values 212, 4, 222. And then on the next line, I'm going to type in regression format my equation. I want to use y1 so it pulls from the table. So don't use y. It won't be able to read that. Tilde instead of an equal sign. Just bear with me. That's how it goes. And then I'm going to type in the other side of it, which is a to the x. I'm going to use x1 so it pulls from the table minus b. That was our equation. Now take a look. It gives me a value of b equals 3. That's what the question was asking for. Let's just test this out and start with 4 and then double it to 8. Look, it still gives us 3. Let's start with 8 and go to 16. Look, it still gives me 3. So it doesn't matter what you use. As long as you double the c, you'll get the same value for b every time. That's how you know you got it right. All right, guys, this next question has come up quite a few times on the digital SAT, and my first recommendation for you is to skip this question and save it for last. This question is a grind. There's nothing you can do except grind it out. It's basically a plug and chug question. I actually recommend to our students, for the most part, that any geometry questions towards the end of Module 2, you'll want to skip and save to the end because they are the most time-consuming and difficult to figure out. All right, we have, I don't know why it says the table. There's no table. So we have the volume and surface area of two similar cylinders. If they're similar, it means they're in proportion to each other. So one is going to be a scalar multiple bigger than the other. Maybe it'll be 4 times bigger or 5 times bigger. We don't know yet. Okay, cylinder A has a volume of 900 pi and a surface area of p pi. Okay, let's start with, they told us the radius of cylinder A is 6 centimeters. We need to figure out the height. We don't know that yet. So over here, I'm going to try to stay organized. We're going to do cylinder A. Volume is pi r squared h. And by the way, you have that on the reference sheet. So you don't have to have that memorized. If you don't know volume of cylinder, don't stress it. In Blue Book, you just click up in the corner, you'll get it. So we have 900 pi equals pi times 6 squared h. 900 pi equals 36 pi h. And then what I'm going to do is I'm just going to divide by 36. So 900 divided by 36, let's go to Desmos. We have 25. That's what I thought. Okay. So our height is 25. Okay. Now we need to talk about surface area, okay? They gave us an equation for surface area, so now we're going to calculate that. So we have the surface area for A is 2 pi times 6 squared plus 2 pi times 6 times 25. So we're going to have 72 pi plus 6 times 25 is 150 times 2, that's 300. So the surface area of A is 372 pi. So what does that mean? Well, if they said the surface area is p pi, P is 372. Okay, let's go on to cylinder B, which this is a little bit trickier, but let me show you the hack here, okay? I'm going to lay out the same thing. So I want to stay organized. I'm going to go, okay, B. We have volume is pi r squared h, 57600 equals pi. We don't know the radius. What do? They didn't give it to us. Here's what we do. They said that they're similar, right? So if I know the volume of one of them is 900 and the volume of the other one is 57,600, I want to know the scalar multiple. How many times bigger is the 57,600 than the 900? Let me find out in Desmos. Okay, it's 64 times bigger. Here's the thing. That is a three-dimensional scalar multiple because volume is 3D. What we need to do to get the actual scalar multiple for lengths, which is one-dimensional, is we have to cube root that. So the cube root of 64 is 4. That means the radius is 4 times bigger than cylinder A's radius. So if cylinder A's radius is 6, we're going to do 6 times 4. So the radius of B is going to be 24. Okay, so I'm going to put that in here. 24 squared times h. Oops, I should put a pi here. Now we can divide by 24 squared pi, and we can get the h. So I've got 57,600. 24 squared is 100. Okay, perfect. So our height in cylinder B is 100. Okay, now we can get the surface area of volume B. We have everything we need. So we've got surface area is 2 pi, radius is 24 times 24 squared, plus 2 pi times 24 times 100. Okay, what's 24 squared? Oh my goodness, that's a big number. 576. So we've got 2. Well, what's 2 times 576? Let's just bang it all out. 1152. So we have 1152 pi plus 24 times 100 is 2400 times 2 is 4800. So 4800 pi. So we're going to have 5952 pi is the surface area of B. So that means this is Q, because the surface area is q pi. They wanted to know what's q minus p. So we're going to have q minus p is 5952 minus 372. Almost there. Do you see how this is a grind? 5580. So guys, make sure you save that for last, please. But this is testing a couple different things, and a big thing is understanding scalar multiples in different dimensions. So if you're in the third dimension, get the scalar multiple, but then cube root it. If they're talking about area and you're in the second dimension, once you get the scalar multiple, you have to square root it. So just do what you need to do to get it back down to a first dimension or one-dimensional scalar multiple, and then you can use it for lengths of sides, radius, anything like that. All right, let's talk about number 9. We have the quadratic function ax squared plus 260x plus c has at least one real solution. What is the greatest possible value of AC? When I see them talk about real solutions, I know we need to use the discriminant. And if they have at least one, if it has one, it's got to be at least equal to 0 or greater. So that means b squared minus 4ac is going to be greater than or equal to 0. Now I'm going to go ahead and put in what I know. B is 260. So 260 squared minus 4ac is greater than or equal to 0. What's 260 squared? I don't know. Let's find out. Good thing we have a calculator. 67,600 is greater than or equal to, I'm adding 4ac to the other side, guys. So it's going to be greater than or equal to 4ac. We're going to divide it by 4. 16,900. So 16,900 is greater than or equal to AC. So that means AC is less than or equal to that. So the greatest possible value of it is 16,900. All right, guys, this is the last one. And like I said at the beginning of this video, it's going to catch you like a deer in headlights if you don't know this simple formula and it's not on the reference sheet. So it says a polygon has exactly 113 sides. If the measure of each of the 113 interior angles of this polygon is 180 degrees, what is the value of A? Okay, here's the thing. We need to know how many degrees there are in the polygon total first. There's a simple formula for that. You take 180 degrees and you multiply it by n minus 2, where n is the number of sides of the polygon. So it's going to be 180 times 113 minus 2, which is 180 times 111. That's the total amount of degrees in the whole thing. But they said if the measure of each of the 113 interior angles is this, okay? So that's for the whole thing. We want just one of the 113 angles. So I'm going to divide the total degrees by 113 to see what each angle is. And I'll set that equal to 180A so that I can solve. Well, you can easily see the 180s cancel, and A equals 111 over 113. And that's your answer. Now, we designed these questions and they're not perfect. If this was a real essay, it's based off of a real SAT question. But if this was a real SAT question on your test, question that answer because you can't grid that in. It's too many characters and you only have 5 spaces. So on your real test, if you get a fraction that's, that many characters, 111/113, you don't have 7 spaces. You can't fit that in. So question your answer and go back to the drawing board. But for the sake of this exercise, that is the correct answer, and that's how you get there. All right, guys, if you really like this video, let me know how you did. How many did you get right out of 10? Did you find this helpful? Do you want to see more? Because I can do more episodes in this series if you really like this. Also, keep in mind, we have our SAT math workbook so you can practice more high difficulty questions like these. I'll link up here so you can go get that. And if you want to go even more in depth with lessons, including like full-on Desmos strategies, we have an awesome self-paced math course that has everything inside of it that you'll need, including bluebook walkthroughs. You can get the course right now for $50 off. Just put in the promo code 50 off at checkout. I'll link up here to the course right now so you can go grab that. All right, guys, thanks so much for watching today. Until next time, happy prepping.